Okay, so we're going to talk about how we describe chemical reactions tonight. So first off, remember, pause the video whenever you need to, write down all highlighted vocabulary, and look out for test question alerts. This is going to be a broad overview. I don't expect you to totally get it today. It's just showing you the basics of what we're doing in class this week. Remember, I reminded you you're going to have a quiz on Friday. So all of this is a test question alert. But if it's okay if you're not sure. We're going to work on it tomorrow. Everything will be fine. So what information does a chemical equation contain? A chemical equation is a way to show a chemical reaction, like the one we saw in class today, using symbols instead of words. And a chemical equation tells you the substances you start with and the substances that are formed at the end. So in our case, we take our hydrogen and our oxygen and we make water. So we have 2H2 plus an O2 yields 2H2O. And we'll talk about why these are 2's in just a second. Those are called coefficients. And the number which is the number that shows how many of each element or compound you have. So this is a compound, and it says we have 2 of them. And so your coefficients are right there. This 2 is a coefficient, and this 2 is a coefficient. And when we balance equations, we change these numbers. We never change the subscript. That's changing things. With that being said, we need to follow the law of conservation of mass, which means mass is not created or destroyed during a chemical reaction. So what does that mean? That means the amount of mass, or the elements on one side, must always equal the amount of mass or elements on the other side. That means it's balanced. And we balance the equations by changing coefficients, not the subscripts. So we change the numbers in front of the elements or compounds, not the ones on the bottom. So how do we balance a chemical equation? So let's take a look at the one I just showed you, which is hydrogen plus oxygen yields water. First thing we need to do is we need to count the number of atoms of each element on either side of the arrow. So I did that, and we have 2 hydrogen on this side and 2 oxygen on this side. So H2, that means we have 2 hydrogens. O2, that means we have 2 oxygens. Then we go to the other side of the arrow. We have H2, which means we have 2 hydrogens, and 1 oxygen, which means we have 1 oxygen. That's a 1. I'm sorry, the font's kind of not. So, how do we fix this? We have to add a coefficient to the side of the equation that isn't balanced. So the side of the equation that isn't balanced is this side. So, just like we did for ionic compounds, each side needs to equal the same number. So we have 2 oxygens here and 1 here. So if we add a 2 to this side right here, then we have 2 oxygens and 2 oxygens. So the next time we repeat this step again, we count the atoms on each side again to see if it balances. Which it doesn't, because now although we balanced our 2 oxygens, now we have 2 hydrogens here. See, we still have H2. But now we have 2 water molecules. So we have to multiply the H2 here by 2. So we have 4 hydrogens. How do we fix that? Well, you can put a 2 next to the H2. Now we have 4 hydrogens over here. Remember, you got a coefficient here, so 2 H2s is 4 hydrogens total. 2 H2s, 4 hydrogens total. Now we have 2 O's, and we have 2 O's, because this is just O2. And you repeat this until it's balanced. In this case, we're balanced, so this is our final answer. So this is our final equation. This is what the equation should look like. This is balanced. This follows the rules of conservation of mass. So, what I want you to do is I want you to try this problem on your own, right here. S2 plus O2 yields SO3. It's a little bit trickier than the one we just did on the bottom of your notes. We're going to work on this in class tomorrow, so make sure you bring your questions. There will not be a screencast quiz, as I told you, because we're going to use this as kind of the quiz, and we're going to get a better visual of it in the lab tomorrow. We're definitely doing a lab tomorrow. Remember, here are your steps, and bring it to class tomorrow. And that's all I have for you.